Thank you very much for coming to the JavaScript panel. So we have a great selection of panelists here to talk about the future of JavaScript. Gordon, whose talk was just on that you might have seen, talking about fantastic devices and JavaScript. Owen, who's going to be talking about serverless later. Caitlin, who's going to be talking about running third-party JavaScript. And Miguel, who's going to be doing his quantum phasing in ACT later on. Thank you very much, guys. Thank you very much. It's great to have you here. Okay, so I want to get started with the developer experience around JavaScript. One of the reasons I moved to JavaScript from Java 10 years ago was for the developer experience. You got immediate feedback. You didn't have to wait for your code to compile. And if you remember 10 years ago, Java didn't exactly compile all that quickly. But I find myself today, especially with front-end code, back in the same situation where I'm waiting for the transpiler or Babel or even NPM to download all the modules. And I ask myself, how did we end up in the situation where this wonderful developer experience, this immediate feedback that you used to get with JavaScript seems to have degraded? So Gordon, because you've built stuff all the way up from assembly, do you think that the nightmare of transpiling is a phase that we have to go through until we get better support? Or are we stuck with it now as the mode of using JavaScript as a developer?
I mean, I would hope that it's just a phase. I think one of the issues is that the benefits you get from running through a compiler and being able to actually type check your code, and for the bigger projects, that's in a way that far outweighs a lot of the other trouble you'd get. But actually, it does seem like an odd phase that effectively debugging has got more or less completely lost in a lot of cases, and for a lot of people, that you're like having a debugger adds so much and productivity to your programming, and also not only a way to avoid errors, but avoid making the same error over and over again and learn things that aren't working the way you hope, and also for performance as well. It's if you don't really know what your code's turning into in the browser, then that's a really bad sign. So
yeah, we've all got bitten by that for sure. Owen, your background is actually similar to mine. You started off in the Java world, although you actually have a computer science degree, unlike me. Where do you think this is going? Are we stuck with this transpiling now?
Yeah, I think we're definitely, I agree. I think we're definitely stuck with it, but I do see it as a positive. Ultimately, we're at sort of the early stages of evolution of the tooling, so that's such that the transpilation time is slow, and but that's something that's going to improve. I tried out a recent development called ESBuild, which is a native transpiler written in Golang, which is significantly faster than any of the alternatives. So I think that's ultimately what's going to happen, because the benefits are there. You need it. You want to ensure that the code size, particularly for browser applications, is going to be small. Not just for browser applications, actually, but for serverless applications too. You're always trying to reduce the code size and do bundling. So you kind of need to have a solution for it. So
you think we're stuck with it, and you think the solution is swallow our pride and go with Rust or Golang as the tooling?
Yeah, absolutely. Yeah, you don't have to build every JavaScript tool in JavaScript. I mean. I think those benefits are enormous. Front-end development has always been hard, actually, and the user demand on front-end experience is just getting bigger and bigger. It's just getting higher and higher. Users demand better user experiences. They have to be fast, very responsive. Load time is important. So the bar is always constantly getting higher. So we just need to improve the tooling. And I suppose that there was just a period of catch-up when mobile development came along, users got used to very fast experiences, and then the web was caught with a lack of tooling to be able to deliver very, very fast responses, and that's where Webpack and Babel and everything that you're complaining about today,
you're not convincing me, sorry. Caitlin, how do you feel about this fact that the code you see in front of you, we're just getting further and further away from that code?
Yeah, so I know from some of my coworkers' experiences in TC39, the JavaScript Standards Committee, that there is actually a lot of work being done to make the plain old JavaScript actually work better, right? So we've seen the ECMAScript modules, being able to use import rather than require in Node. We've seen, the experimental mode there in Node, allowing us to use that. And I think basically what we're seeing is that being able to use the type module in the web page, things like that, we're actually getting more out of transpiling these things and squishing them down into the minimized JS, and actually being able to use the real modules in the web page and in Node and things like that. So I think we're moving away from it. So I may differ a bit, but I think that's a really good thing.
You think the browser ultimately will support us as developers, so that the browser is essentially doing this work in the background for us?
So I think what we're going to see is that standardization is going to be helping us make this transition. So it's going to be on the all of the hosts, all of the browsers, things like that, are going to be supporting these standard module types, so that it's not just that Node has its own weird way of doing things. It's that there's standardized JavaScript ways of doing it. So.
Miguel, you have the benefit of coming to this world fresh and not having suffered all the terrible ways of developing, even going back to the 90s. I remember seeing Netscape came out with server-side JavaScript in the late 90s, and I remember looking at it going, no way am I ever going to do this. 15 years later, I'm doing Node. Without having the burden of history, what is your opinion? How do you feel about working with JavaScript, coming at it from a modern perspective?
All right, I'll start off by saying that I've been using JavaScript for 5 years, right? So I've got some also bad experience in it. As a matter of fact, I feel that today things are getting much better. I mean, I was very used to using libraries like jQuery and other things, for instance, for web development. And nowadays you have things like $sign that is natively supported by JavaScript, and queries, functions, and everything seems to be coming into a point where JavaScript is going to be much better than it used to be. And it used to be 5 years ago for me. Maybe for you, it's 100 times better than it used to be. And I really feel that although we have a lot of things that are building on top of things, and we are kind of losing focus on the lower level stuff, I feel that it's a trade-off between functionality and things that we get out of the box, and things that we can really understand. So if you really want to, I think you can still develop things in JavaScript that you understand. But of course, it's a trade-off, and it's not going to be easy to get away from all the hustle of using all of these like languages like CoffeeScript and TypeScript. They appeared for a reason, right? So we'll see, but I'm hopeful. I'm hopeful for keeping on using JavaScript, and I'm not feeling like it's a burden at the moment.
I think that's. I think this is the message from the panel, is that things are getting better. The question is whether we'll stick with transpiling or not. Can I call for a vote, actually? Do you want to see the transpiling tools, Babel, and that stay as part of the ecosystem, or would you prefer for them to die away? So put up your hand if you want them to stay. That's less than 50%. And put up your hand if you want them to go away and just not be something you have to deal with. Okay, that's a plurality, maybe 40%. You can't deny that there are certain advantages to the tools, as Caitlin pointed out and Owen pointed out. And you are dealing with a language that was written in 2 weeks, so there's always going to be gaps. But perhaps the way around this problem is to not use JavaScript at all. Perhaps the way around it is to start using WebAssembly and start using other languages. What do you think, Gordon? As someone who can code in assembly.
I think for some things it will be very useful. I would hope that people wouldn't all start using WebAssembly. So I guess my thing is that if every web page was written in C, the web would be a very different place and would be much more difficult to use. I feel. It depends why you're going to WebAssembly. If it's as part of a bundling process where you develop in JavaScript and then you try and you effectively do it as an optimization process before you ship, kind of as a form of minification, then maybe that's okay. But you know, if it's a tool to get something running on a web browser that you wouldn't normally have done. So I guess a good example is, you know, I've been at companies where I think Alistair possibly mentioned you have a big black box of code that some guy wrote 50 years ago before he retired in Fortran, and no one dares change it. And even though you wouldn't, in an ideal world, you would change it, you would rewrite it, you would make it better. You know, that's not what happens. You've got this blob. If it means that you can then run that blob in the browser, make everyone's life nice and easy, and have it running very quickly and in a user-friendly way, rather than running on a server somewhere with, you know, seconds of delay between requests, then it's a big bonus.
Absolutely. And I mean, you're focused more on the serverless end of things. So where does WebAssembly fit into that? It feels redundant in that context.
Yeah, I mean, yeah, I would say so. I would say so. I mean, if you're going to write serverless backends in Rust, you're going to do them in Rust and compile them to native.
Exactly.
I'd see, you know, WebAssembly is really an opportunity for people who aren't comfortable with JavaScript on the client to have an alternative, and I think that's a good thing, actually. But I'd kind of not like to see it become too popular, in that, you know, JavaScript is a very productive language, gives you a lot of freedom, a lot of developer creativity. So I'd like to see WebAssembly succeed, but only in areas where it's really necessary to optimize, you know, hotspots within the code base. And maybe, you know, within frameworks like React or Vue, where they've got, you know, have to do virtual DOM diffing, and therefore, you know, you've got hotspots which necessitate some level of optimization to make applications run faster.
Okay, and that's a browser-specific use case as well.
Yeah.
Caitlin, in terms of running third-party JavaScript code, which is the subject of your talk later, if that code is being compiled down to WebAssembly and that's what you're given to run, surely that makes your job more difficult in terms of making sure that code is safe, or is it easier, perhaps?
Yeah. So it does make it more difficult. So there are certain security guarantees that you get at the JavaScript language level. So for instance, you don't have access to an object, right, unless you're given access to it, right? So JavaScript has unforgeable references, unlike C, right? You know, so in C you could try to guess a pointer, and then maybe you've actually gotten it and you can get the data at that pointer, right? In JavaScript you can't do that. So for WASM, this is an area that I'm not that familiar with, but some of my coworkers are. I know there are certain JavaScript language guarantees that actually are not met at the WASM level if you try to bring everything down to that level. So, but there's a proposal, I think it's called WASM GC. Somehow this is connected to the garbage collection. I don't quite understand that, but there are certain proposals that are trying to fix that. So I think we're going to see, if people do WASM right, hopefully we'll be able to maintain the same security guarantees that we have at the JavaScript level at the WASM level, but that remains to be seen.
So Miguel, the interesting thing about quantum computing, and if anybody has actually looked into it, and I believe there are some really interesting tutorials that kind of take you through the mathematics behind it as well, which is something that you have to learn. The binary nature of the whole basis of our ordinary programming languages, it's not really appropriate. And you end up with this world where you have to deal with things like qubits. And does having a compilation target like WebAssembly make your life easier?
Okay.
I have no idea what the answer is going to be.
Okay, this would be probably a very long answer. But what I will focus on is saying that when you're handling things like qubits, you usually want to focus on using them for computation. So you're writing an algorithm on top of it directly. So what you can have is a phase before getting into that code that will resemble some sort of assembly code. And you already have a few things like that. But in terms of trying to put both things in the same bag, I think it will be complicated, although it might be interesting in a few years. So the thing about it is, a lot of these concerns that pertain to getting good standards and getting good performance, I think they'll only come. It's a bit like JavaScript. You build something that works, and then you start building on top of it. So I think we should wait for me to answer that.
Okay, go to his talk. That's the way. That's the way to find out. You mentioned something interesting there, which is JavaScript is all about building stuff on top of other stuff that people have done. And one of the most amazing things about the JavaScript ecosystem and about the Node ecosystem, especially if you were there in the early days, was the phenomenal growth of NPM. How it just completely took off, right? Before that, you had CPAN and you had various other artifact repositories. But the Node one just took off and went completely crazy, and you got hundreds of thousands of modules, most of them quite bad, most of them with security flaws. And we've had all sorts of interesting things happen with developers canceling themselves and completely removing all their code, or code being maliciously taken over. And we now have this really difficult dynamic where it's very easy to participate as an open source developer directly in the Node and JavaScript ecosystem. But at the same time, you end up depending on hundreds of other people. Hundreds of other people end up depending on you, which raises not only security issues, but also raises issues around, as an open source maintainer, how do you participate effectively in that ecosystem? And I think it's a problem that we haven't yet solved, and which is really important to the future productivity of JavaScript developers. So this is a two-part question for each member of the panel. First of all, how do we deal with this, these huge dependency trees? Have we gone down the wrong path? Should we try and pull back and in some way reverse what's happened, or should we embrace it? And the second is, if you participate in this ecosystem, do you implicitly create for yourself a burden or a responsibility to everybody else in the ecosystem? And if so, if you're just doing this in your spare time at the weekend as a hobby, we've seen lots of people get burnt out from trying to be a good citizen. So you have people who just open up their entire code bases, which leads to all sorts of security problems, or you have people who tightly control it, but then are working 80-hour weeks on a hobby. It's not a hobby anymore. Gordon.
Yeah, I mean, I think in terms of like being part of this dependency tree, creating a huge amount of modules that you're dependent on, I wonder whether, again, it's a sign of the fact that everything's moved so quickly and the tools haven't quite caught up. You know, already we've got ways for NPM to try and check for security risks, and perhaps there are other metrics it could work on. So maybe you could, when you're searching for a package to do a specific task, you could actually look at the number of dependencies and whether those dependencies, you know, can effectively be merged with other packages that you're using. Because, yeah, at the moment, if you want to solve a specific task, you're basically Googling to try and find out that task. You find a few different packages, and then either you try them all out, or it's very hit and miss. If you had a good way of finding out something that was an efficient solution to your problem in line with all the other stuff you're using, that would probably...
And people have tried to do this, right, where you have some sort of curation around the packages. Mm. And one of the pushback from the community around that has been that it excludes people. So if you were there in the early days, your package is going to win. So we see some interesting things happening to try and address that. So Michael Rogers, who's one of the original Node people, wrote a module called Request, which was the first sort of professional grade HTTP request client. And he has recently completely put that module to bed. That module is now totally deprecated, and he says don't use it anymore. And if you read his explanation, it is explicitly so that new modules that are better can start to become the prevalent ones. So it's not so easy, I think, just to say there needs to be curation and there needs to be some way of deciding, somebody who decides who the good modules are.
Oh, no, I wasn't necessarily saying curation, but just that that some way of actually figuring out when you're looking through a bunch of modules, you know, programmatically, what their dependency tree is like. Because often you just install one thing and you think it really should be there to provide a very simple task. And if you actually look at it, it's installed like 400 modules. And if this goes out through a whole project, you end up with this massive tree.
I'm not going to let you write that answer just yet. That is fair enough, right? But the problem is that's going to be true of almost every module. So you still end up with analyzing a tree. You still end up trying, this module might have a different tree to that module, but it's still a very deep tree. I don't know if that solves the problem.
But if you make it something that, if people care about it, and people obviously do care about dependency trees, especially now that tools are checking the dependency trees for security issues, you're more likely to have more security issues, I guess, the more modules you depend on. If you make that something that people care about when they're selecting packages, if you want your package to be more popular, then you will try and make your package dependent on packages that, you'll try and reduce your dependency tree as well. So if you provide people the tools that they can actually see what's going on, hopefully over a period of time, people will start to change the way packages are made.
Owen, to kind of bring us back to the core of this question, as an open source maintainer yourself, and as someone who has to use a large number of node modules for enterprise projects, how do you address this issue of having such a big dependency tree and yet having to maintain a level of quality for your clients?
My answer is probably similar to the answer to the very first question, which is that the benefit of it outweighs the disadvantage. So I think, you rightly say the success of Node was, just ballooned with the proliferation of all these tiny modules. And small components in software are really effective. It makes it very easy to be agile in how you develop and swap in and out components and experiment and innovate. So the benefits are there. Ultimately, I think what I'd like to see is some sort of content security policy where I can install a module and know what it has access to, in the same way that when you install an app on your phone, you have to explicitly grant it permissions to access the file system or the network or whatever native resource. If I deploy a Node.js serverless function, I can give it access to very specific minimal privileges in a cloud environment. But at the moment, it's actually quite difficult to say, but don't give it access to the disk, or don't give it access to the internet, so it can't steal my environment variables, take out secrets, and post them to somebody's email account.
Okay, I like this idea. So in this way, you're effectively just whitelisting what modules can do. And at least one source of frustration I have, and I don't know, Caitlin, perhaps you know if this is still the case. There is a way to create a sort of internal VM in Node itself. But if I remember correctly, if you read the documentation, it says don't use this for security purposes. It's not. Does it still say that?
Is that the built-in Node module VM?
Yeah.
So I don't have any expertise in that in particular, but I will say that in JavaScript already, there's the concept of a realm, right? Like each web page that you run JavaScript in is a realm. And so, JavaScript that operates in one web page can't affect JavaScript that operates in another. And so there are a number of proposals that are going through TC39 right now that are trying to take this idea of a realm and make it actionable for security. So you might be able to create a new realm, or you might be able to create an even lighter realm, and I'll go into this more in my talk, that allows you to execute third-party code safely. So I think people are kind of taking that concept and they're actually bringing it to real life and allowing people to use it. But to go back to your earlier question about the dependencies, I think the number of JavaScript dependencies that we have, and the fact that NPM has I think over 800,000 different packages that you can use, that's a fantastic thing. We should be proud of that, right? And I think that the fact that we can't see the entire dependency tree, that's a problem security-wise, but if we look at how real life works, I don't know how the bread that I had at breakfast was made, right? I don't know who made it, I don't know where it came from. If we get the security right, that's fine. I shouldn't have to know those things. But what we have to do is we have to create the environments that allow us to get the security right.
Okay, I think that both of you actually touched on an interesting point. Give me a minute, Miguel. So I want to go back to Owen and Caitlin on this one, because it strikes me that perhaps we should invert the problem. Perhaps it's not so much a consequence of having used JavaScript as a consequence of software development moving towards the idea of finally having a composable architecture where you can pull together lots of small modules. And perhaps JavaScript is just the sort of canary in the coal mine because it's so easy for us to have small modules. But if you think about the wider question, surely this applies to all languages really at the end of the day. In the Java world, which is the only other world which I have a great deal of experience in, that problem was solved through curation, right? You had Apache and people like that and IBM, and those were the guys that you trusted. And speaking for myself, I still apply that mentality in the world of Node, right? So I don't know if any of you are familiar with the Happy.js ecosystem and that web server. And I just trust that guy and all of his stuff, and I just use as many of those packages as I can, and that's the way I kind of reduce the problem space for myself. That's not optimal. So I think we should perhaps think about this in a little bit of a wider sphere. Maybe this isn't just JavaScript's problem. What do you think, Owen?
Yeah, I mean, yeah, you're right. I mean, in theory, the same problem applies to Python modules, but you don't have as many small modules in Python, so it hasn't really manifested itself in the same way, but I agree, it is a general problem. I think Java solved it, you're right, with kind of Maven, but it also made it very difficult. I mean, I've tried to publish public open source jars in the last couple of years, and it's amazingly difficult how much friction there is. So therefore, people will just be discouraged from using it. So I think we have to be permissive in allowing people to publish, and then encourage people to just be restrictive in how they consume. And that's really the way forward.
Caitlin, I just want to get your take on this.
What part specifically?
So in terms of the small module approach not being specific to JavaScript, is this actually a wider trend in the software world? And in particular, how does that apply to security?
Right. So we've definitely seen what they call supply chain attacks, I think, in other languages as well. So there might have been a Ruby gem attack, Python we mentioned. So I think you're right that we're seeing it from the JavaScript side because JavaScript is so widely used and it has so many packages. So it is kind of the canary in the coal mine, I think. But one of the great things about JavaScript is that it already has this clear separation between kind of the pure computation part and the outside world. And a lot of languages just don't have that separation. So like anything that you get from the host, like window or document or something like that, you could potentially just cut off all of the access to those things, and then your JavaScript doesn't have access to the network, or it doesn't have access to the file system, or the things that are really dangerous. So like I've heard, and I'm not a Java programmer, but I've heard that Java, for instance, it's really hard to kind of make that separation because things are too embedded. So we actually have something in our favor in terms of JavaScript and security.
Miguel, after having heard everybody, what's your take on this?
Okay, so you asked two questions. The first one is are we over the edge on using modules? I think we are, but I don't think that's a bad thing. What I think happened is JavaScript became something so worked on, and with so many people giving it a background, that it became so tempting for big companies to use it. And so if I use it on my personal projects, I don't think it's problematic if there's a security flaw, or at least it's not as much as a company deploying something in production. So I think it's good, but we do need some way of curating this, and we need to do it in a scalable way, because we cannot have someone go through 8,000 packages and trying to find if they have security flaws and so on. So I think there needs to be there's a need for something that's scalable, and that's a way of curating it. As for the second question, as an open source developer, I kind of only find that open source developers at this point can only do it for the community. They cannot do it to make money. Like you can get some incentives, and GitHub, for instance, has a sponsor program now, which is supposed to give some background on it. But I don't think it's working as they intend to, or at least not at this point. One other thing that GitHub is doing very well, I think, is for each, and this happens with node modules, for each repository they say how many times this was used, or how many other repositories mentioned this one, which is, I think, is also a good way of curating some things, because you get a good sensation of how many people use it and how trustworthy it might be, even without a standardized way of auditing for security flaws and so on.
Thank you. I think the message for me coming out of this discussion is there's a tooling gap here. I think this is, it's an interesting space for somebody to step in and start helping us solve this problem. Okay, last question. Nearly at the end, guys. Well done. This is the one where you make a fool of yourself. And they're recording this, so you can look back in 10 years. What is going to happen to JavaScript in the next 10 years, Gordon?
So I'm kind of slightly biased about it because I was brought to JavaScript because I liked the fact that it had a very clear grammar, or almost like Java at the time, where you could pretty much have a A4 cheat sheet of everything you needed to write code, not how to use the inbuilt APIs and stuff, but how to actually write an algorithm in it. And it feels like every year there's a new version with more features that, in a lot of cases, early on, effectively, features really filled a big gap. They let you do something that you couldn't previously do. But recently, I feel like features are just adding extra fluff.
You write your own parser, don't you?
yeah. So I have to deal with all this.
Yes.
Every year, I have to deal with all the new stuff, which is also often written without much of an eye to the people who are writing the parsers. So often it's not very efficient for parsing or very fast, which every year it makes the compiler writer's job harder. It slows down the interpreter as it tries to parse all these potential different grammars. So yeah, for me that's a slight concern going forward, is the sort of the bloat of the language past what was needed, especially as it gets to the point where a lot of people are transpiling and they're not using all these extra features really. They're just using the base that's needed, which is basically the output.
So you don't predict, you hope rather that people can just leave it alone.
I predict it's going to get bloated, but I really hope they're going to stop.
You hope it's done. Owen, where do you think JavaScript's going to go?
I don't know about 10 years, but I think I kind of feel like we've peaked in terms of JavaScript's ascendancy. I don't think it's necessarily a bad thing. I mean, it'll continue for the next 10 years in browsers for sure, but I think more people will be writing TypeScript than JavaScript ultimately. And it's not something I do myself actually very often. I like dynamic languages and I like the frictionless nature of it, as long as you're writing small components. TypeScript is useful when you've got large projects again, which is a little bit of a red flag, but sometimes you have to do it, and there are good use cases for it. But I think TypeScript has been very well designed, and it's kind of an unstoppable force at this point. The tooling is fantastic for it, so I really see, just as you had the dominance of Java kind of in the early 2000s, ultimately other languages emerge and it becomes more of a level playing field, and JavaScript won't dominate as it has in the last 10 years. So
history doesn't repeat, but it does rhyme. Caitlin, where is JavaScript going to go?
So I think we were right when we were saying earlier that JavaScript, was kind of had this attitude of you put it out there and then you clean it up afterwards, right? And I think we're going to see an increase in the amount of cleanup and refinement and learning about best practices. So if you look at what the JavaScript Standards Committee was trying to do, their main imperative was don't break the web, right? So it's really hard to clean things up after the fact when you don't want to break, what people are doing right now, right? But they were able to introduce JavaScript Strictmode, right? So you could choose to put, the strict imperative at the top of your file, and that would enforce, certain restrictions on what your code could do, rather than the kind of sloppy mode that was usual. And so, we've seen, like Doug Crockford has this great book, JavaScript, The Good Parts. So you can take this kind of very messy language and you can extract the parts of it that are really good, and you can enforce these certain restrictions on your own code and the code that you use. And I think we're going to see certain parts of the JavaScript ecosystem become more refined and just really embrace better practices.
Okay, so I'm going to have a positive view now. I think, from what I've seen in the past years, JavaScript is really taking over things. Like you see libraries like, for instance, Nest.js and other libraries for backend development. They're completely replacing what we used to do in PHP and so on. Then you have a lot of libraries that are open source from Google and Facebook, like React and Angular and so on. And those are really taking a good stance of the market. And then you have multi-platform development, which you can do in JavaScript. And although it's not as good, as fast as native code at the moment, I think it's walking towards a very closing that gap. And so, and even you can, that's the point. You also have libraries for using machine learning with JavaScript and quantum computing with JavaScript. So the question is, what can't you do with JavaScript? And if the answer is nothing, so why should it stop, or why would it? You know. So I'm confident that it will stick along for the next 10 years.
So full speed ahead.
Yeah.
100 miles an hour. Thank you very much. You've been absolutely wonderful panel. So we have a few minutes. Would anyone like to make some comments on the future of JavaScript, or indeed any of the other points that the panelists made?
I'm actually from outside the JavaScript ecosystem, and one thing I'm always wondering is why don't you guys have a standard library? Wouldn't that solve a number of issues about proliferation of packages and trusted and curation?
Yeah, I'd love to have a standard library. What do you think, guys? Gordon?
I think there is, to a certain extent, there is a bit of a standard library, like, you know, all the functionality in string and regular expressions.
Yeah, but it's rubbish. We need more.
Yeah, it's, well, yeah, I don't know.
How do you respond to that? I couldn't actually tell if you were being sarcastic or not at the start, Richard. Yeah, I kind of go the other way. I mean, part of the success of it was that we didn't have a standard library, and that you had this composable set of modules around it. So, I mean, I've never really actually felt the lack of a standard library to be a problem. You have a lightweight core, and then you pick and choose around it. That's my opinion on it. I know that, say, for example, you have this response then. So Golang came out with like this very complete and robust standard library, you know, and that draws, you know, a huge response. So it's interesting to see how that kind of dynamic works. But I'm...
LeftPad wouldn't have happened with a standard library.
LeftPad?
LeftPad, yeah. Yeah, it's true. It might be something else. I don't know.
Yeah, I think the example of LeftPad is a really good example. So for those of you that don't know, this very widely used package just got taken out of the ecosystem, and then everything that used that was just broken, right? So I think that means that we need some kind of redundancy, right? We're missing the kind of infrastructure that you would actually want to have in an ecosystem like that. But I think the fact that it's not centralized is actually a good thing. Ideally what you would want is a competitive landscape of different packages that you could choose from. And maybe, you know, if LeftPad wasn't there anymore, you automatically already had a backup or something like that. But I think it goes back to what Gordon was saying about having more information or some way of sorting through the packages so that your competitive landscape is actually an informed, you know, decision, and not just like, oh, this package looks like it'll do what I think I want. Let me install it and let's see if anything bad happens, right? So I think we have a long ways to go in terms of actually making the package infrastructure work correctly. But I don't think centralizing all of the functionality is the way to go.
I would actually add that I think it makes sense to have something of a standard library. For instance, what makes Python very successful is that it already has a lot of things you can import without installing it. But I don't think you can have everything on it, and you will still need to have these packages. So even with the standard library, and I'm not opposing to it, I actually think it would be a good thing, you still need to have some space for people that are building sometimes redundancy or redundant things that are already in the library. For instance, because they want to focus more on performance or something like that. So it's not something bad from my point of view, but it's not something that's going to make JavaScript much better than it is at the moment.
Thank you. Do we have any more comments, thoughts about JavaScript?
Yeah, I think it's not a program of the module and the ecosystem per se. You know, that's an extra. You can always write everything in vanilla JavaScript, and write your own modules and everything. It's just like if you are lazy and you just want to take module, then that's your own problem. You need to take risks, and then it's your responsibility to evaluate those modules just for safety and the dependency tree and everything.
So it comes down to a trade-off between getting the stuff done, but taking personal responsibility for the modules that you import. And do you feel it? I'll put this to the panel. Do you feel? I mean, that is a valid point, but do you feel it's actually practical? As a JavaScript developer, I often feel under pressure to deliver, and it feels very hard to assess the dependency tree.
I think your thing about JavaScript giving you flexibility is really good, and I feel it's a little bit like C in a way, or C++. There are a million ways to shoot yourself in the foot with C++, and if you're a company that's developing a project with it, you're almost certainly going to have coding standards. Otherwise, you're going to end up with a completely unmaintainable tree, and I think that's probably something that's just that just has to happen with JavaScript as well. You have to have standards about which features you use of JavaScript and how you choose the modules you're doing, even if only right now that's because of licensing concerns. But yeah, I think it's very powerful, and as long as you don't use everything that's available to you, you can actually produce some really good maintainable code in a very productive way.
I think the free lunch is over in terms of just consuming modules and forgetting about them and thinking, it's the open source maintainer's responsibility to give you perfect software. So I'd say, the tooling is there actually. You've got NPM audit, you've got Snike, security audits are available. You also have to do all the sensible things. I mean, security problems are just going to increase. So multi-factor authentication on your NPM repo, using a proxy for NPM so that you've got your own artifact repository as well. These things, they're responsibilities that we're just stuck with now, and we just have to adopt them.
So part of my background is actually in food safety, and I think there's an interesting analogy here because imagine if someone said well, you can eat the food that someone else sells you, but if you really want to be smart, you got to grow the wheat yourself and then make the bread, and then you got to control the whole supply chain, right? People would say wow, that's so much work. You must be insane, right? And so I think. We're building up these packages. We have this rich ecosystem of code, right? And what we need to do is kind of add the layer of civilization on top of it. And so part of that is maybe more curation, more auditing, things like that. But I also think because it is code, because it's not physical items, we have a unique situation. We can actually start out with perfect security. We can start out by putting things in the realms and the compartments that I was talking about earlier, and not allowing any authority to get in except what we explicitly grant. So because it's code, we have this unique opportunity to try to do things differently and to actually be able to use other people's code safely.
I'll just add quickly because what you said makes a lot of sense. If you want to do an MVP, if you want to do something really, really fast, or if you want to compete with a company or with a startup and so on, and you're using JavaScript, it's not going to be feasible to develop things from the bottom up. So I really think there's that. Yeah, I agree with you that this is the way to go. Although there's some trade-offs, there are some things you can do, and there are some things as well that are going to help the situation.
Okay, I think that's a wrap. To summarize the discussion, one of the really interesting takeaways for me was this idea that perhaps we have entered a brave new world of small modules. It doesn't just apply to JavaScript. It's a universal problem that I think is going to come to all software engineering. And we have to grow up and be civilized. Thank you very much.